Okay. Howdy, everybody. How's everyone doing? Good.
Howdy.
Howdy. Everything
Hello,
good?
hello.
Okay. Okay. So let's see. For today, we will do two set of presentations. Basically, I condensed 2 weeks from a normal semester to one single week because we only have 2 weeks total. As a reminder, I think this assignment is due on the 20th. So you have about 8 days left to do this. And just make sure you start early and you watch the videos and all that because they're very helpful. So let's start with this part right here. This is for last semester actually, but I think it's a great way to break down a problem to smaller problems so that you can tackle each of them, by line, and then you can combine them together, to create a finished product. So you need to make sure that your server runs as a child process, a single data point test, a single data point test two. You have all of this. This is actually the same thing as you will see on the server. On the GitHub, it will test all of this. And then you have multiple data point tests, and then you have new channel test. Basically, what your goal is, you have a single data point test right here, and then you can use it to scale it to multiple data point tests, because multiple data point test is just literally calling single data point test like 1,000 times. And then you have a new channel test where you have to create a new channel. And I will show you in a bit what that means. Okay, so first of all, let's go over a little bit of FIFO. So actually, I think this is from last semester. So FIFO, when I first learned about it, I thought, oh, FIFO is transferring things over the disk, but that's not the case. It is actually going through between the server and client through memory, through the shared memory. It's through a pool of memory, so that it go to server, it's sent to a memory address, and then from that memory address, the client can receive it, and then the other way around as well. It's actually just there's no disk IO in here. FIFO special type of special file similar to pipes, except that when exchange data via FIFO, the kernel passes all the data internally without writing it to the file system. Thus, FIFO special file has no content on the file system. The file system entry nearly serves as a reference point. That's all. So if you ever think, oh, it's slow or something, this is something that I did not understand until like last semester. So it's something to share it out there. So FIFO is actually really simple. You have two things right here. You have a server and a client, and then the server. In the server, you have and then you need two pipe for communication, because each pipe can only can only send and receive data in one direction. So you need two pipes, one for writing to the server and one for writing to the client, or the other way around, reading from the server and reading from the client. So you server, you send, it's called FIFO control 1 and FIFO control 2, because when you start the program, FIFO control 1 and FIFO control 2 are the first two channels that you established. If you send a quick message, which we will go in a bit, I will show you in a bit. If you send a quick message to to FIFO control 2 from the client to the server immediately shut down. So that's why you need to, it deletes FIFO control and immediately shut down. So if you're going to make a new channel, make sure you create a new you delete the new channel first before you delete FIFO, or else you will be killing the server before it has a chance to, destroy all the old unnecessary communication when it's gone, right? So make sure that's one thing you do is quitting FIFO control 1 or FIFO control 2 must be done at the very end. Yeah. So I think this is when, yeah, so this is when you wow, this is the first, yeah. Anyway, wait, why does it look so weird? Is it because, oh, okay. So the data message, okay, so now we're talking about a single data point request. So what you do is you create a buffer right here. So a buffer size 256 bytes by default. Actually, if you hover over max message, I think it's like max message. That's the maximum message size by default, provided by, you know, when this programming assignment was written, which is 256 bytes. So what you do is you pass that struct data message that you initialized using the pass in parameters that you know the user gave to you, and then you pass it in the buffer using memcopy. And this is why I told y'all that memcopy is a very important function, is because we're going to use this a lot during this assignment. So if you still don't understand what it does, make sure you come back and you know spend a little bit of time talking about it. So you have a little struct data message right here. You memcopy it into the beginning of the 256 byte, and then you send the buffer to the server, and then the server will return all the data necessary. And then what you do is you want to make sure you pass that data, because that data is in a pointer form. So you also need to, you know, memcopy it back into not this time, not into a buffer, but into a double, because it's returned back a double, right? So that's how you get a single data point. Is that you data struct this into the buffer, and then send this buffer to the server return back the double, and then you use that double to display on the screen. And that's how you get the single data point. And then for multiple data points, you just, you know, do this 1,000 times. You just send forward, backward, send forward, backward. So you have a loop. Or in my suggestion, I always suggest, and you will see it in a bit, is we're going to break it down into functions. So in this case, you have a function for single data point, and then you have a function for multiple data point, and then a new channel functions. So that with the single data point function, it's pretty simple. And then you with multiple data point, you just, you know, call the single data point function 1,000 times, so that you don't have to deal with the same formatting 1,000 times, and it improved readability of the code and the debuggability of it, because then you only have one point of failure to debug instead of thousands of points. And then the new channel is just to encapsulate it, and I will show you in a bit how it looks like. But that's how it basically it. Let me put it. Do y'all have any question yet for me? Nope. Okay. Does that make sense? Makes sense, right? Yeah. Okay.
I actually have a question.
Yes.
So how exactly, like, I think I, for the most part, understand how memcopy works, but when you copy like an object into a character buffer, it just stores it bit by bit. And then when you copy it back in to another object, like it just converts it back. I guess I'm kind of confused on how it stores it.
So you're saying like, how is it be able to store a data message into here?
Yeah, because you can store any object into a char buffer.
Yes.
Is it because it, like, a char is just 1 byte? So if you get the size of whatever object, you know, the amount of bytes, then you can just make sure it fits.
Yes. Right.
Okay.
So it's char buffer. It's just a fancy way of saying a 256 byte memory chunk, right? So that you can store any data, any bits into it. At the end of the day, 1 is 1, 0 is 0, right? So it doesn't really matter as long as you know the correct order of the information. You can always, you know, decrypt it. Not really, it's not decryption here, but more like encode it and decode it. Well, in this case, you just have data message. It's a struct, and it's all you know, it's comprised of 1s and 0s, right? So if you copy all ones and zero using memcopy into the car buffer, it's ultimately still data message, but in a more, in a non-structural form, so that you have to take it out and then put it in again and then send it to the server. The server will deal with it. You don't have to deal with it, thankfully. And then just whenever it returns back, you can use cread to get the data out, and that's it. It's yeah.
Okay, thank you.
Yeah, that's the whole point of memcopy. It copy you bits by bits. That's it.
Okay.
Yeah. So now that's one thing, and then another thing. So that's the first thing. This is just an overview of it. Now this is the actual real first thing you want to do is fork. You want to make sure you have the server. So with the server, with a fork, what you're going to do, your goal is this. You will use the client as the parent and the server as a child. That means that's the reason why we do this is so that you only have to run the client. The server will be run automatically when the client is ran. So in this case, what we do is we're going to use fork and exec. Well, there are multiple flavors of exec. Fork, what it does is for a process running processes right here, right? It's okay. We call it the client, and let's treat it as a parent. What it does is it's with fork, it spawned the exact same copy of the parent, and the child spawned the child with the exact same code as the parent. So let's say the client. Let's ignore these letters for a second and think about. So this is code for the client.cpp. When you fork, it will spawn into the client.cpp and another client.cpp, another child with all the client.cpp code. So the goal of fork is just to get you to spawn processes. It really doesn't do anything yet. The magic happened when you do execvp. What execvp does is it replaces whatever in the process that you executed in with the code of the new binary that you target. So in this case, execvp, you pass in the server binary, and it will replace the entire code of the child, which is previously the client.cpp, with the server.cpp. So that now you execute the server within the child, and the client is still executing as a parent. Does that make sense? Okay. So yes. This is the first thing you want to do. Yep. So I think I explained this to Cassie before, so I think it's pretty simple. And I will tell you that by understanding this, in the exam they will test you over this stuff. So make sure you understand what exactly fork does and exec does, and how it actually affect your data. So that if you do fork, right, the data of the client and the server might be separate. Depends on the situation, and you will understand it when you start doing the fork and exec in the server in the assignment. Yep. Okay. So here you go. Here's an example. So here you have the client right here, and let's call the so whenever you fork, it will return PID. Does everyone know what a PID is?
Yes.
Yes. It's a process ID. So it's for each process, to identify each process. Let's see, chat. Yes, I will go over execvp in a bit. I will go over it once again in a bit. Okay. So in client, you have PIDT. Okay. So let's call this a variable PIDT, and let's call it fork, right? Fork right here. So that in the child, then the child, so it will now spawn. It will now spawn into two processes. the child will be returned. The way the way the process know if it's a child or a parent is by the return value created by fork, because fork will return two PIDs. There's PID for there's if a PID returns 0, that means it's a child. So in this case, and then if the parent, then it will return the PID of the child, which is some value greater than 0, basically. So if you see, if PIDT less than 0, right, there mean it's a fork error, you just end the program immediately, which I never seen fork error before. So that would be interesting. So if PID equals 0, or if you can do like not PID, right, then you do exec VP, because then it's only execute within the child, right? So that exec VP, because exec VP destroyed the entire old code base, and then old code base, and put the new server.cpp in. That's why you should only do it in the child. In this case, if PID equals 0, then you exec VP. Else, then you continue whatever the code that is already written for you at the bottom. Okay. Does that make sense? Okay. Okay. Yes. So Deshanta talked to me about doing the exec VP. So let's go over exec VP a bit. Or exec. So exec VP is just another flavor of oh, what the heck? Sorry, 1 second. Okay, there you go. Let me zoom it up so that you can see. I don't know how to zoom things out. Oh, right here. There you go. Beautiful. Sorry, actually, I think my dad is, singing karaoke at like 9 a.m. right now. So if you hear anything, sorry about that. Man, exec VP. Okay. So you can see, if you ever feel confused, or if you don't ever remember any of the system calls, or the Linux command or something, use type man and the command that you want to understand, or the function. You can just do that, and it'll give you this Linux programmer manual. It's very helpful. So the first thing I always read is a synopsis. In this case, you can see that how exec VP work. It pass in the file. It's a car array of the file. Basically, it's the binary. It's the name of the binary that you want to target. So in this case, I want to say server. A server, then I would just pass in the server constant car, and then I have all the argument of argv. This is also include the constant thing. Yep. Yeah, I will also explain that in a bit. Oh, you have to use arrow key. Why is it the case? I don't know. Let's see. Exec is a family. So you can go over this actually, and it will tell you exactly what is. So let's say exec VP. These functions duplicate the action of the shell by searching for an executable file for a specified file name does not contain blah 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 blah. All of this, you can go in and understand it a little bit more, but it's really not bad. It's really not. I use exec VP, but you can use any flavor that is suitable for you, and that it should be good. Regardless, it basically your ultimate goal is to execute the server. That's it. On inside the client. That's it. So that's for sure. It's good. Okay. So okay. So there's that. Okay. So you go. So let's see. So you want to cast a string. What if you want to cast a integer as a integer as a constant char so that you can pass into your buffer. What you have to do is you first, this is a multi-parts, and this is how I did it. Maybe there's a better way, but this is how I did it. First of all, you need to import the std string, right? Not the regular string, not string.h. I think string.h also worked, but I don't think so. It's like you have to import string, right? And then what you do is you have the number. So let's say integer m, because that's the buffer size, and let's call it 256, right? And then what you do is, oh, let me make this a little bit easier. Then what you do is you have to convert this to string by first initializing it. So string, initializing, calling the constructor and passing the value string of m, right? I think this is the right one. I think it's string m. I might have to check it one more time, but basically you pass the m value into the string constructor, right? And then what you do is you have to convert it to a C string, because that's what execvp wants, a C string. But the problem if you do this is that it's not enough, because C string will return a non-constant string character. I think that's the case. Let me Linux. No, see, sometimes you don't remember, just pull it up and then give you think. Why is this always like this? Okay, man, C string. Does it? No, it doesn't have it. But basically, yeah, it return a non-constant C string, so that I have to cast this as a constant char, right? So I do constant cast char, and then wrap the whole thing around it as well. So that you have to do all this long thing to pass in the m value into the buffer. And let me pull up the Chrome, and I will go to github.com. Let's go to my LE. No, not LE. Sorry, PA1. I think min is a better way to search for this. PA1 right here. And if I go to client, I hope it's not too much. Should I pull down? So much. I have to zoom in a little bit now. Okay. Yes, so you can see. Yes, so right here. So it wants, you have to go to string. Yeah, my bad. So this is what you want. So you do to string, you pass in the buffer capacity, which is, to string is just, and then you would C string it out and the constant cast it, and then you would get the full name. So you have to make, so basically you have to go to std string. So this will convert the m to std string. Then from std string, you do a C string right here. And then from C string right there, you have constant casted, then it would work. So at multiple steps, it's kind of complicated, but that's how it is. So there's that. Let me close this. Okay. C. Yep, that's how it is. It is how it is. Okay, so any question for me about the first part? Again, it's just you understand how to do the first, you understand how to do the package to send it to the server for a single data point. You scale it up to 1,000 data point, then you would be able to do all the casting, and then you can run as a server, as a fork, using fork and exec, as I told you, and then you can search information about it. And the new channel, you just have, it's already, you already see, you actually in the starter code, you see an example on how to establish a new channel. You just send a channel message. There's a channel message in your, check your common.h. I think it's common.h. Let me pull it up. Common.h. PA1, I think is common.h, right? Yes, right here. So you have a file message, you have a data message. There should be also a channel message that I've been, oh yes, right here, new channel message. If you send this to the server, it will send you back, it will send you back it will send you back a channel, a channel name, and then you just put it in, you put it into a car array of 100. It's called 100, and then what you do is you just establish connection by using the new using a FIFO constructor to pass the name of the given name by the server to the constructor, and you would get a new established channel. And then you make sure you send from the same channel. If you want to quit a channel, you send a quit message from that exact channel you want to quit to the server and delete the channel. And then that would tremendously, that would kill the channel and you'd be done. And again, make sure you only quit the control channel at the very end, not the very beginning. Does that make sense? Any question for me? Does that clarify everything? Okay.
Yes.
Okay. Okay. That's good. Okay, so let's go to the second part of the presentation. So I think it's like my drive and teaching and this and somebody and this. Okay. Oh, that's not the right one. There you go. Okay, so for week 1, part 2, this is just the beginning that we talk about it. So let's talk about file transfer. So with file transfer, you have to it consists of 2 phases, okay? So getting the file size. So basically, you cannot transfer a file without knowing the length of a file to request. You can, if you remember, if you transfer a huge file in Windows or in Linux or in Mac OS, you drag and drop from one location to another, and the first thing it does is like calculate the size, right? That's right there. You always need the size first before it can start transferring. And also it's to give you the progress bar and stuff like that. So the first thing you want to do is, getting the file size. And then the second part is transferring the file. So an overview. Okay. So let me, yep. So an overview, you can see things clearly, right? Okay. Okay. So the overview, you have the offset right here. The offset is the current position of the transfer. So let's say if the offset equal to, so let's say if the min homework folder.txt, if the size of the file is 500 bytes, then if the offset equal to the size, that means the transfer is complete. Otherwise, the offset will keep moving from left to right until it's done transferring. Yes. And so you have the offset of 0, the length. So the length right here indicate the length of the transfer that you want. So let's say your buffer size, remember, is 55. Your buffers, if your buffer size is 55, then every transaction can take only 55 bytes from the server to the client, right? So that means you have to transfer, the first 55 bytes, the next 55, 55, 55, all the way until the very end. And it will explain a bit what happened to the last 5 bytes if it doesn't fit the buffer. But for now, you can see that it's keep transferring 55 bytes at the time. And then, it keep transferring until, and then for every successful transfer, the offset will increase by 55 bytes. So the first one is 55, and then the offset will be is 0. Then the next transfer, the offset will be moved to 55, and then it will transfer the next 55 bytes from byte, I think 55 to byte 109. And then you keep going and going until the end. Does that make sense?
Yes.
Sorry, 1 second. Somebody's calling me. I need to turn on this. Okay, so So there's no question? Y'all good understanding this so far?
Oh, no. So when you were saying goes from 55 to 109, wouldn't it be 110, or am I misunderstanding?
Sorry. So it's from byte 0 to byte 54, right? Because it's 0 to 54 is 55.
Oh, right. Yeah,
Yeah.
my bad.
And yep, that makes sense. Okay, cool. So that's that. So you can see here, your file, this is what you can see in the comment.h. You have the file message class right here. It has a message type, offset, and a length. And then in file message constructor, you just set in the file message for the m type and then offset and length. So you want to make sure you get the you have the offset and the length always ready. So how do you get the size of the file? Well, what you have to do is the client will send a file message, okay, with 0, that indicates that you don't actually want any byte. So the 0 here, which means the length is 0, and the I think the offset is 0 and the length is 0. Sorry, let's see. Oh yeah, okay. The file message, the length is 0, the offset is 0. That means you indicate to the server that you only want the length of the file that you want. So you pass in the file message, the file name, and the no pointer at the end. And I will talk to you about a no pointer in a bit. Is the length always going to be the same size as the buffer until the last data transaction? Yes, it's indeed. Because the last transaction, it can be 55 bytes, but it can be 5 bytes, it can be 10 bytes. You don't want to pass all 55 bytes in, because then you get all the 45 garbage bytes, which then cause the file to be corrupt. So you want the exact amount of bytes that the file has. So you send this to the server, then the server go check the size in the BIMDC, and then it will return the length in byte back to the client. So, yep. So on the last, I need to handle that correct? Yes, you also need to handle that correctly, and I will show you in a bit how that works. So for every packet that's sent to the server, like every single packet that you send to the server, and you don't know what packet is the thing that we already talked about, the buffer. You always send the file message offset and length plus the file name plus the null terminator for the C string. If you use string copy, you don't actually have to include the null terminator. But I'm a very old brain person, so I use the C string for this just because it makes more sense in my brain, and I use mem copy for this. So it's whatever you prefer. So how do you calculate the packet size? So because before you can even create this packet, you have to create the size of the packet first, right? So the packet size will equal to the size of file message plus the string length of the file name, and then plus 1, and one more space for the null terminator. So I think assume the size is 24 plus 10 plus 1. That means I think the number of bytes for I checked this. I think the number of bytes needed for the file message is 24, and then you need the 10 bytes for the file name that you want, and then the 1 for the null terminator, so that it would be 35 right here. And then I would create a car packet, a new car equal 35. Make sure if you do this, you have a delete, haha. And then packet pointer will be here. So the packet pointer, right, will start at the position 0, right? Because it's an array, it will start at the position 0. And then what you do is you use mem copy to packet file size message 00, and then your size of file message. Then it would be putting the first 24 bytes into the first 24 bytes position of the packets that you just created of size 35. Okay, does that make sense?
Yes.
Yes, right. You pass file mem copy from packet file message 00 and size of into here. So the first 24 bytes will be that. I think Mary already talked about this, so it should be just a review. And then what you do is you move the packet pointer beyond file message. In this case, you do packet. So the first parameter, again, remember with pointer arithmetic, you can move the pointer around by adding to it. So in this case, I do packet plus size of file message to skip the file message already written portion, because if you don't do this, it will just override whatever in here, and that doesn't work. So you have to do packet plus size of file message, and then file name plus null terminator, a string length, and then file name. And I think with string copy, you do the same thing, but you don't do the null terminator. It will deal with it for you, I think. You can check. I think Mary do the string copy, so you can go to her video to check it one more time. I watched it and then I completely forgot that part. Yeah. So does that make sense?
Yes.
Okay. Okay. That's
I'm a little bit confused with the second argument, file name plus /0. I'm assuming that's just for the null terminator.
Yes, that's for the null terminator. Yep. Yep. All right. So that's how you get the construct, and then you send it to the server using C, right? And then you receive back in a double format again, or an integer. I think it's a double. So you just get a double, and then, that's the file length that you need. So that start the transfer file. So again, you start with this thing that I already talked about. And then what you do is, let's say the buffer is 55, the size is 500. Now, so the first process, you can see that it transfers the first 55 bytes. The offset equals 0, and this offset and length are in the package, right? The file message. So the offset was set to 0. The length will be the buffer capacity, which is 55. So then you send it to the server. The server will return back the first 55 bytes. You write it to the file using OF stream. Make sure in OS, I think it's OStream, and then make sure if you do OStream, there's a binary mode that you need to enable, because if you don't enable it, it might just write it as a traditional text file. So make sure you enable binary mode so that you can transfer it into the file in binary form. So that that's for first 55 bytes, and then offset 55 right here. You do again, you set, now that you're done with the first one, you set the offset to 55 now. So it started the byte 55, and then the length is still buffer capacity, right? You transfer the next 55, and then 55, and then 55, and then 55, 55. The offset keep increasing. So it will be 55 now, and then 110, then 165, 220, 275, all the way to 495. Okay. So while offset is less than size, keep transferring. You just keep transferring. It's a loop. So this is literally a loop for you. While offset is less than size, keep transferring. So ensure to not read too much. Though what happened at the very end? If so, in your code, you have to check if offset minus if size minus offset is less than buffer size. So in this case, size is 500, offset is 495. So 500 minus 495 is 5 bytes. So that is definitely less than the buffer size. What you do is you set the length equal to size minus offset. That's it. So that then you only transfer, and then when you do C read, right? You have to make sure you only read that many bytes. You only read the first 5 bytes of the C read, right? And then you just put it in the file. And then that's it. You're done with the file. Does that make sense? Okay. Does things make sense? Or is there any question?
Yeah.
Okay.
I do actually have one question. I used the OStream to write it into a file, and I didn't put it into a binary mode.
Does it work?
But it does work. But do you think I should do that just to be safe?
So make test work with that?
Yes.
Okay, if it works, that's great. I'm not really sure why that, maybe
that's one thing I was getting confused with, though, is because it does like write the file properly. Like if it's like the CSV file, you can see the text. But then if it's a binary, like I couldn't see that it was.
So have you tested it with other type of file? Let's say you transfer a PDF, it would work.
I did it with a video file, like 100 megabyte video file, and it worked.
And have you have a chance to do diff You know the diff command?
Yeah, I did do the diff and compared them, and I got no error. So.
Okay. If that's the case, that's great. So that I don't have to deal with that. Yeah. So then O stream. If that's the case, then that's great. Yeah. Okay. That's what I learned. Yeah. As long as there's no error. I think I said it explicitly or something. I don't remember. I think that's why that's what my thought process. But if that works, that's great. That's great. Okay. Hang on. Let me see. Can you go over the last bit? This bit? Yes. Okay. So again, let's say you want to transfer the last 5 bytes, right? So how do you check to make sure that it's the last 5 bytes, like something that is less than 50, ideally 55 bytes? Well, what you do is in your code, you have an if statement that keeps checking for every single transfer. Is this smaller than the buffer size? So if size minus offset is less than buffer size, right? So if size is 500, offset is 495, then 500 minus 495 is what? 5 bytes, right? Then that would definitely be smaller than the buffer size, right? So then what you do is you do length equal to size minus offset instead of length equal to buffer capacity, right? So like in previous one, you do buffer capacity. So in this one, you do size minus offset. So then that would only transfer the last 5 bytes. And you want to make sure that when you do C read, right, you don't C read the entire 55 bytes. You C read the first 5 bytes of the C read. Here is the thing, the channel read from the FIFO, the function. Then it will only read the first 5 bytes because you don't want to write all 55 bytes into the file because that would cause file corruption, right? So that's it. Does that make sense? Okay. Cool. Okay, so we put things together, and I always talk about modularity in the course. I really don't like repeating the same code over and over again. So this is my recommendation. I don't force you to do this, but I think it's better for you. It's better because it's just easier for me to look at the code, and it's easier for you to look at the code because then you would have so much simpler things, and it's break down the problem to smaller problems so that it's easier time to keep track of what you have solved and what you still have to solve. So in this case, I have a request patient data point where it passes in the FIFO request channel pointer integer p double s and e, so that you just have it abstract away the mess of code, right? So that you can just plug things in, and then it would it would make things a lot easier in read in main. But if you get things to work, you don't have to deal with it, and but it's just something I recommend. And then with request patient data, it's just calling request patient data is just calling this and return like 1,000 data point and exporting it into the file, CSV file. So it's just calling this function. So again, you can see it promote code reusability because you just reuse this function over and over again. And then the same thing, the next 2 function is for file transfer. So there's a request file length right here that will request the file length, and then you use the transfer file to call the request file length, and then you transfer it to the server. It's pretty straightforward. And then the last 2 function is just for channel, creating new channel. So you have one for creating new channel, and then you have one for removing channel. So that this one will communicate with the server and return the new request at the new channel. And then this one just you pass in the FIFO request channel, and it will just remove the channel for you. It's really it should be pretty simple. So you have 2 functions for this, 2 function and 2 function for data message, 2 function for file message, and 2 function for new channel. Does that make sense? Okay. And I think Josh did something like this. Yeah, so that's one of the person. Yep. So you can see, because you do this, right? Because you do this, you can see how clean my main is. I literally have, this is my entire main. So I have double data request patient, and then that will just return patient. Else, if get specified, I just call this, and that's it. Actually, I don't know why I passed t equals 0 here. You don't need it because you can see my request patient doesn't even need it, but it's there. And then for file message, if f name exists, right? If you pass in the f name in the get opt, then transfer file, just do this, and then auto, for auto. Well, this one you don't have to care much because this is how I create multiple channel just to test with the 1,000 channel. Make sure it can even create 1,000 channel, but you don't have to really deal with it that much. But you can see remove channel. That's it. You always do the control channel at the very end, and that's it. And oh, and one thing I learned, thanks Gabe. Gabe is a TA last semester. He's a very cool guy. He actually gonna write new assignment for this class, but he's very cool. So size of checks for the length of the array at compile time. So it does not work with dynamically allocated array. So I think a lot of people misunderstood this, including me, is that you try to do size of on a new an array that was dynamically allocated with the word new, right? If you do that, right, because it's dynamically allocated, size of only check the length of the compile time, while new does that at execution during execution, so that size of does not know how big the array is. So it's always going to return the size of 8-byte, which is the size of the pointer, because 8-byte is 64 bits, which is the size of the memory. So if you pass around your buffer into a function like I do, make sure you send in the capacity as well. That's just something that I recommend. And you can see right here that I always pass in the buffer capacity right here. And then I think that's it, because you really only need the transfer file buffer capacity right here. But yeah. Okay. And then the last thing is time your code. This is for your PA thing. For your PA report. All you have to do is you do time and you do .client f data. And I personally use the sys, but it depends on the system as well. Because some system real. I think it's real. I think it's one of them. But the goal is for you to see the difference. You can see, and you will observe this in your data, is if you start with, so this is by using a default, which is m equal 256, right? By default is the buffer size is 256. You see it takes about 13 seconds to transfer, but then if you increase the buffer to 512, it decreased by half, right? And then you double it again, decrease by around half again. And then again, half, again, half. So you should see this pattern when you do time.client to make sure that your code is working as intended. And then it should be good. But if you don't see the sharp decrease whenever you increase the buffer size by increase by 2 times, then there you might want to go in your code and you want to check and make sure things are it's actually changing the buffer size and actually things are passed into the buffer. Yep. So yeah, that's it. Any question for me?
I have a question. In the document, it does say for the testing, there's like a mention of testing with data point requests. But I was kind of confused on that because when you do the data point request, like the buffer size doesn't really matter that much because you're only like need the size of like a double. So I was kind of confused on that part.
Let me see. 1 second. Let me see. Repository. I think it's like this one. Then you have, where's my PDF file? Oh, right here. Wait for it to be done. Logging in. Okay, cool. Okay. I think that's the only graph I have. Wow. Okay. me see. So I think it's in modules. And I think it's in P1. Dude, it's always lags. I don't know why it lags on my computer. Always like, what? Sorry, my dad is still singing songs right now, karaoke next door. So now it's echoing in my room. Oh my God. I hope you don't hear it, but yeah, I don't know why it's on a Sunday that he decided to sing so loud, crank up the music to 100 and then start singing. Okay. Let's see. What exact part is it?
So if you go to the tasks and then requesting file, then report down a little bit, the next page. When it's, yeah, it says timing data you collected for data points, text files, and binary files.
Yes. So it shouldn't matter. And if you observe that, then you're good. Like if you can observe that and that, because I don't think you can change the files. Honestly, the files, the data points, like 1,000 data points, I think it's scaled by, the amount of data points there. So each point, as you can think is as atomic, which means you cannot get something smaller than that, right? So if each data point is atomic and that you cannot change the timing for each atomic, then that means that the time needed to transfer data points should increase at the same rate as the amount of data point that you want. So let's say one data point take 1 millisecond, then 1,000 data point would take 1,000 millisecond or a second. So you can see it scaled by a linear amount. While text file and binary files, they also scale linearly with the buffer size, right? The buffer capacity, right?
Yes.
Yes. So
Okay.
that's it. As long as you can observe some interesting, stuff and you write about it, you explain why you think the way it is, you're good.
Okay.
Yep. And then make sure you include this in your, and then I will grade it. And then also I just want to tell this moment to tell you that starting with PA1 to PA4, there will be hidden test cases that only that we test during the grading. So you won't even see it. You won't even see this test case to pass it or anything. You just do it and you get 60 point, then we regrade it with the first 60 point plus another 40. I think it's 40, maybe I'm wrong, but basically there are hidden test cases. The thing is, don't worry, if you pass it and you don't hard code, the reason we do this is so that you would want to make sure you don't just hard code things to pass the test cases. So if your server can handle a range, if your server can go through the entire graph. So when I took this class, I made a graph for the length like this. If you can do something like this, you can dynamically rearrange the file. I mean the parameters and alternate the parameters and make sure it's clean and working just fine. Then you're good. You don't have to worry about it. But like it's just something that I put it out there just so you don't some people might be starting to hard code to pass the test cases. Yeah, please don't do that.
Yeah, I was going to ask about that because it says in the prompt as well that you can expect all the inputs to be like valid.
Mm-hmm.
So I was struggling to come up with other things that I might need to test besides testing different types of files.
Like you should be fine. Yeah.
Okay.
I will tell you that it was a non-issue last semester because we tested last semester on 300 students. And I don't think it came up that often that, we have to manually regrade things and stuff like that. So you're fine. As long as you can pass this 60 points with a good looking code that doesn't really, hard code anywhere, you're good.
Okay.
No, there's something you have to hard code, but yeah, don't worry too much about it.
And for the report,
Mhm.
there's not like a ton on the structure. Do we just do like introduction, talk about what we're
Yes.
doing?
Mhm.
And
Basically,
then
yes, sorry.
well, no, go ahead. I guess, yeah, I was thinking like introduction, talk about the process, and then have a graphs or whatever you need, and then conclusion, basically.
Mhm.
Okay.
So as long as as you talk about your codes, basically that part is to make sure that you understand what you're doing instead of just mindlessly copying something. Then it's just to make sure that you understand. So as you can see, it's in mine. I explain how it works and how you don't have to write this long. I'm a very lengthy guy, so I talk a lot. But you don't have to write this long. At all. You don't need a page and a half. But I talk about how I did this so that I understand it a little bit more and stuff like that. But yeah, that you as long as you explain your code, you're good.
Okay.
Yep. So I think, is there any other question? I will be here until, of course, 11. So, you can either work on it or you can ask me question or anything. Well, I'll be here. If not, then I will first of all, I will end this session so that I can upload it on YouTube. So I'll stop recording.